Alright, so today we're going to practice to add and subtract fractions. Let's begin with proper fractions, and then we'll move on to mixed numbers later on, as well as improper fractions. But we're going to start off with an example. Let's say we start with 3/4, and we want to add to this 2/3. Remember that we had a couple of rules for adding and subtract fractions, and we should note these down just so that we can recall them. So when we add, or subtract fractions, we must have a common denominator. Okay, let's remove this. That's a subtract. Okay. So when we add and subtract fractions, we must have a common denominator. Notice in our example here, our denominators are 4 and 3. Common just means that they must be the same. So in our examples, right now, the denominators are not the same, and so we need to figure out a way to make them the same. In our class, we introduced the butterfly method, and that's a really great way to show this, and we can note this down, the butterfly method. And so the butterfly method is it's a shortcut of actually finding common denominators. What we want to do is we want to find what we call equivalent fractions. Equivalent fractions. So I'll write that over here. So equivalent is just another way of saying that they are equal. So this is what we're saying, that these are going to be equal terms. We practiced in the past how to work with equivalent fractions, how we can make the fraction either larger or smaller. And the way we do it is we will need to multiply both the denominator and the numerator by the same values. So already we've been practicing with our multiples, and we should know that multiples of 4, so we can go 4, 8, 12, 16, 20, and so on. And same thing with 3, we can go 3, 6, 9, 12, 15, etc. And we want to go until we can find the lowest common multiple. And in this example, we see that 4 and 3, their lowest common multiple will be 12. And we can always find a bigger one, that's fine. We just will need to reduce in the future. So we know that 4 times 3 will give us 12. Well, when we talk about equivalent fractions, how did I change the 4 into a 12? Well, I had to multiply the denominator by 3. And whatever I do to the denominator, I have to do to the numerator, because this will give me what we call equivalent fractions. It's not changing the fraction, it's actually giving it the same amounts. So if we really simplify this down, 3 divided by 3 over here, right? So times 3 times 3. But this line means divide. So we have the number 3 divided by 3. What we're really doing is we're just multiplying it by 1. Is this a fancy way of looking at 1? So 4 times 3 gives us 12. So 3 times 3 will give us 9. Likewise, in order for the 3 to become a 12, we had to multiply the denominator by 4. And now we have to do the same to the numerator. We need to multiply that by 4, because 4 divided by 4, this still equals 1. So we've only enlarged the kind of proportion of the value of the fraction. It's still actually one full piece. We can look at this again when we look at a pizza so that you can see an example. But 3 times 4 gives us 12, and 2 times 4 will give us then 8. And the addition is still there. So now that we have common denominators, once we have common denominators, remember our other rule was that we can only, so when we add and subtract, the denominator will stay the same. So we're only going to add the numerator. So in this example, we have the 9 and the 8. Oops. We have the 9 and the 8. So we're going to go ahead and add those up, and we're going to get the 17 over 12. And that will be our final answer. We'll focus on converting these. This is what we'd call an improper fraction because the numerator is bigger than the denominator. But we'll be working on converting these in our later classes. To go back, and I wanted to just show you the butterfly method because we kind of skipped over that really quick. We can say 3 over 4 plus 2 over 3, and we said we can do this butterfly. It looks like a butterfly, so we can multiply 3 and 3, and that will give us the 9. We can multiply the 4 and the 2, and that will give us 8. Then we can multiply the denominators, 4 and 3, and that gives us the 12. So this is kind of a neat method to help us find the same answer, but recognize that these are still equivalent fractions. So we still have the 9/12 over here and the 9/12 over here, and the 8/12 here and the 8/12 here. Okay. To see how this might work as a subtraction, it actually works the same exact way. We're going to go through the same method. So we'll practice this again. We'll start off with the 3/4. This time we're going to subtract the 2/3. Okay. So equivalent fraction says, I know I want to get the same denominators. I know that 4 and 3 make 12. So how did I get the 4 to become 12? I multiplied by 3. So that will give us 9 at the top. I multiplied the bottom here by 4, so the top has to be multiplied by 4. That will give me 8. So now this becomes much easier. 8, again, we just focus on the numerator. 9 minus 8, that will give us 1 over 12. So that's our final answer. To just help you out to understand this a little bit further, so if I were to say, for example, equivalent fractions. So if I wanted to draw a circle, let's go ahead, and we talked about that pizza or that cookie example. Okay, so if I cut this cookie in half, right, we can see that, let's say that I have this piece over here. So we can say right now that I have one piece, and how many pieces are there in the entire whole, the whole pizza? In this entire whole pizza, there are 2 pieces. Okay, but I have one of those pieces. Okay, so equivalent fractions, as we were saying here, is as we are moving this, as we're multiplying by a larger value, what we do to the numerator here, so we multiply that by 3, we must do to the denominator here, where we must multiply by 3. So I'll give you the example of the pizza again. So here's the pizza. I have 1 out of 2 pieces, but let's say I wanted to cut that pizza again. So let's use purple, I guess. Let's say I want to cut this pizza again. So I'm going to cut it in half again. Okay, I'm going to cut it in half. And notice now that the pizza's cut in half. I no longer have one piece. I actually now have 2 pieces, right? So we have the 1 piece here and the 2nd piece here. So I have 2 pieces. But also the number of pieces has increased as well for the total amount. So the total amount I can count here, there's 1, 2, 3, and 4. So there are actually 4 pieces now. So even though this is, even though I have more pieces now, my pieces are smaller. So this is an example of equivalent fractions. The whole never changed. I still had one whole pizza, right? I had one whole pizza. But the amount that I got increased, but notice it increased while it was increasing, the piece also got smaller. And while the number of pieces increased as well from 2 to 4, those pieces also became smaller. So this is how equivalent fractions work, and again, what we use when we add and subtract fractions. To recall this, I just want you to practice and remember the 2 basic rules. That is, when we add or subtract a fraction, we must first have common denominators. If we don't have common denominators, we cannot add or subtract. And the second rule is that remember that once we have common denominators, when we add and subtract, the denominators will stay the same. So only the numerator will change. In our example of addition, the numerator got larger. In our example of subtraction, the numerator got smaller. The denominator, notice in both instances, remained the same. It was still the 12. Okay, so we'll continue to work on these in class, and I'll give you more examples. Post questions in the chat or bring them to class and we'll discuss them. Thanks.